The second talk is about lazy evaluation, as I said, and it's short, so if you guys have questions, please interrupt me anytime. It will be like very formal, if possible. So let me... Lazy evaluation. But before talking about lazy evaluation, I would like to start from useless languages and the path to the nirvana. I don't know, I mean, if you know the classic diagram from Simon Pitton-Jones, like Colin knows, yeah, this is where I'm going. But I'm going to start from this. So this is side effects. This is a perfect example of side effects. That switch, it's connected to a light, but also the elevator, okay? This is the kind of programming languages we're working on a daily basis. This is the exact example, right?
Where did you get a picture of Cocoa Parts?
That picture? This is coming from crappy design, the Reddit subreddit. Anyway, so the point is, we work with effects, we love effects. We do things, we burn montage, we do many things with effects. But we're trying, in our path to the nirvana, try to control those effects, to try to don't burn houses. We want just maybe launch missiles, but we don't want to burn houses, okay?
Specific houses.
Yeah, exactly. So, Simon Pitton-Jones, by the way, I left a link of the YouTube video. It's like almost 20 years old, this video, so it's kind of like old stuff. But the point is that you can start with the programming languages that we use every day that makes you give whatever you want. And there are other languages that try to get to control this effect, to try to make something more safe. Please.
Is that supposed to be the C language?
Yeah, it's not official, yes.
Can I take exception to that then? Find the programmer I flip those two?
That is a good point. The idea is to say at the same level, but yes, I completely agree with you. Those two should be switched.
There might be more amazing side effects in C.
Yeah.
Especially when you get pointers.
And because we're there, I'll also move Scala on the left, way more on the left. Yes. So this is completely bonus. So, okay, forget about this diagram. Okay? But the idea is we have languages that are completely side effective. Okay, you can do side effects anywhere, and other languages like Scala that are trying to control that. Those are the questions. Okay. Why we are trying to get on the right-hand side? Because Simon Pitton-Jones was saying that, you know what, in this top right corner, there is the nirvana. We are trying to improve our languages to try to get to the nirvana. And in the nirvana, we have useful programming languages. We can argue, but I think we can actually, the common ground here is that these three languages are actually useful. We can actually build cool stuff. But we're trying to get on the right-hand side, controlling their effect. And on the left axis here, we also have useless languages. So we're going from useless languages to useful. No, it's not me, it's Simon doing that. So this is, there is a link here, you can check it out. So basically, lambda calculus. Lambda calculus, you cannot interact. You just, you know, transform things.
It's really unsafe though. If you only have one type, I push it. It's even worse.
Okay. So the idea is that there are other families of languages. There's another family of languages that basically is trying to get to the nirvana from another angle. So they're trying to control the effects, trying to get them from useless to slightly useful. Okay. This is Gabriel, and basically it says that Haskell has effects, but the effects are first-class values, and these are not set effects. So basically, just to go after your talk, so basically those two couple of slides at the end, talking about the Iona, that's exactly what I think Gabriel is talking about. Haskell is trying to be like pure wherever it can, and have side effects, have effects as first-class values. Okay? So again?
Where would you place Rust?
Where do I press Rust?
It's coming at it from the other side. No, Rust, the origin of Rust is C.
Yeah,
it's
that's-
coming at it
it's
from the other
there.
direction, but it is approaching that control side effects and labels.
Yeah. What is JavaScript?
JavaScript.
Next
Bottom left.
So there's a question.
Hey, so I want to understand the assumptions that you're making
A second, sorry.
So I want to understand the assumptions that he was making, right? So is it that programmers are stupid and they need to be controlled by their language?
Yes.
Or right, if I'm an expert C programmer, I can write perfect code.
That is correct.
And if
yeah.
no one else has to touch it, then it's fine. And so I might have fully controlled the effects by my best practices.
Exactly, yeah. So basically, I'm saying that, look at me, I'm getting old and I'm getting bad in handling effects everywhere. And sometimes I have to make like negative states. So I need to have rails where I can drive. When I use parametricity, I feel way more safe, way more safe. Yes, and so basically, yeah, it depends on the developer. Of course, you can actually have just NANDs and you can build whatever you want, even a processor. But the point is, why not using something already safe? So yeah, the answer to your question, as far as I understand, is yes.
I think the other argument there is that most of the time, even when you're writing C and a legitimate perfect C, you still have types in mind anyway. You've still got some monolithic programming towards, and you'll just manually keep that up to date ahead rather than letting the language take care of that many task for you.
Sorry, this is Alan.
Yeah, but to be fair, I mean, that's not the only axis that you want to measure it on, right? Like we talk about C having side effects. Well, C has, like bounce checking, obviously, it's very easy to write a C
Yep.
program that has straight But side effects, to me, they're not the only measure. Like the
That's
one
correct.
example that comes to mind the most is list macros, right? Like it's very easy for a developer who doesn't really have a grasp of like when the right time to use macros is to use that to write a list program that like no one understands. And it's like, wow, okay, there's like 30,000 lines of lists.
Exactly.
Use macros that I have no idea what any of this does, and it's completely unexplainable. So, I mean, there are other axes that you can measure.
Sure.
The quote unquote safety of a language rather than just side effects.
Yeah, that is correct. That brings the question.
Like a circle or.
The question is why I'm doing this? So why I'm bringing this very old chart? This is like 20 years old. So why I'm bringing this if I want to talk about laziness in Scala versus Haskell? Why I'm doing that? Thank you for the question between the lines, Alan. And before going to answer this question, I would like to say one thing that Simon mentioned is that these two families keep cross-pollinating them. So for example, you're using like kind of monads in this side, think about C#, Scala, or in this side, look about the SD monad used by Haskell. So using like transaction in this way. But anyway, let's go straight to the answer, to the question. So why we're talking about effects when tonight we want to talk about laziness. So let's have a quick look about evaluation models. And I want to just show 3 different models that I think the most common ones. One is the call by value. We are very, very familiar with this one. So this one is when basically you call a function and you know that the arguments you're passing gets evaluated straight away. Okay? This is like item C. Every day we use that. And we basically assume that could be even possibly just the only way to do it, right? I mean, to some extent, somebody maybe could think that. So why this is super cool? This is very cool because we know exactly what's happening where. You know that feeling that C developers have, oh, I know everything is under control. Yes, because it's very simple. You know exactly when things get evaluated. Oh yeah, you have the control. Okay? Okay. So for instance, if I have a function that is calling the first argument release monkeys, and then increment counter as the second argument, we know that from left to right, first we release the monkeys, and then we increment the counter. And even it doesn't matter if f is not even doing anything with the return value from those two functions, right? This is completely like call by value. This is everyday code. So when side effects are allowed, that's the point I want to make. That a strict evaluation is actually what I want. I don't want to think too much because if the whole world could change, the whole world is like mutable or side effecty. Personally, I prefer to be in a strict evaluation kind of rule. The next one is the call by name. It's slightly less common. It's very common like in Scala, you can see. And the only difference is that you pass the argument, and these are evaluated. So inside the function, we're gonna use them. So basically, think about substituting inside the calling function, substituting that argument with the implementation of that argument inside the function. In other words, you don't evaluate before calling the function, but inside, if you call that argument multiple times, you call it, if you pass a function, you call that function multiple times because there's kind of substitution.
So it's kind of like a macro?
It is kind of like a command, yes, yes. I wasn't sure about bringing this up because all I really want to show tonight is call by name. So basically, I really care about call by value, call by name. Call by name is like a middle step because at the end of the day, call by name is very similar to call by name, but it's different. Similar, but different. So what's going to happen here? And this is Haskell, okay? Haskell, even R is doing that. So Haskell, when you call a function, you're not evaluating the arguments. No, you just pass them, and you know at some point when your program needs to actually evaluate those arguments will be evaluated, okay? So, okay, what I'm trying to do is try to bring like bad things about lazy evaluation. So if you are working with call by name, it's hard to reason, it's hard to understand, you can do it, but it's hard to understand when that thing will get called, okay? So if you, let's say, it's not possible in Haskell, but let's say if you can do like side effects, that's a big problem because you don't know when that side effects will be happening, if you don't know when your stuff gets evaluated, okay? So it could become like very unintuitive. So here we go. That's another big statement. If you do lazy evaluation, essentially you want to choose purity. Okay. Oh, there's a question.
So in call by name, when you say it's only evaluated once, what is the point at which it is evaluated? Oh, is it all times? Is it,
I think,
what is the one?
yeah, I think I have a slide about that, but the quick answer is, let's talk about Haskell, and please correct me anytime. And again, double check on the internet, don't trust me. It's pattern matching. So, okay, at the end of the day, when you compile an Haskell source code, there's a big machine with lots of stages, and at some point, there's a language called core. This language is a very small type lambda calculus that all it has is basically pattern matching. So when you pattern match, when you do what we showed in the last example, that pattern matching thing, only then, when you get the parameters and you have to do something with the parameters, only there you evaluate the expression.
Well, okay, so I mean, are we talking about like at the call site of the function? Like because I mean, like with call by value, it's very easy, right? Like they're evaluated at the call site, right?
Yeah,
You call
that
this
is
function,
correct.
then I evaluate these parameters. In the other model.
Call by name, forget about call by name. Yeah. That's very Scala. I'm going to show an example.
In that case, it's evaluated every time you reference it in the code, right? Like every time that reference comes up, you have to reevaluate that and say, what is the value at the point at which I'm calling this inside the function? So
Yep.
that's what I'm trying to figure out what the intuition is with call by need, to figure out what is the once that is evaluated. I mean, is that a call site? Is it?
Effectively, you're passing in a value, which is a promise to evaluate the thing.
Right.
And if it ever gets evaluated, it actually is the machinery in the runtime system which will replace itself by the actual value. It may not be evaluated all the way down either. If you've got a list, it will only evaluate enough to see whether it's like, oh, I've got an element or an empty list, and the rest stays lazy. But you know, it will kind of say replace that thumb with the actual value.
Right. Right.
We're going to see an example, exactly that example. I'm going to show the example in a few slides. No, it's perfect. So we're going there. So there's a question there.
I was just going to say, I think the long story short is things get evaluated when the result is demanded by some sort of IO operation, right? So like, write this variable to disk, and when that happens, it will be forced evaluated, right? That's sort of the bottom line.
Right, and that's kind of like the outer layer, I guess. But if you're sitting there poking stuff in the JXCI, the IO is very implicit. It's just pretty.
Yeah, and then there's like the whole read and level form, pattern matching stuff too, but
Let's get
yeah.
on to that.
Yeah, we're sorry.
We'll see. It's okay. We'll see that.
The first time you can no longer reason about engineering.
Right. Because, right, I mean, part of the reason why I ask is because I think about this, being pragmatic about it, right? I think about it in pragmatic terms. I have a developer who is trying to reason about the code that he's writing, right?
Reason about the code, yes.
Right.
I'm
Call by
listening.
value, right? Call by
Go,
value,
brother, go.
It's
Keep
very
going.
easy to reason about that. And they have hard rules, right? There's a hard rule for them to be able to reason about, I know when this value is being evaluated, but with call by need, it gets murkier, right? Like it's much harder for a developer to reason
So that would assume that you can have the same kind of modularity with call by value as you can with call by need. So what will quite frequently happen, so have you done any like game tree stuff, like this kind of thing? In the call by need language, you can actually just define a whole infinite game tree. And it won't actually look at it. It'll just kind of evaluate down as far as you actually need. So now you can modularize the production of game tree and the evaluation of game tree. You see what I mean? So now, whereas if you're doing it call by value, you have to kind of bind them together, otherwise you run off. I'm keeping it in the right. Okay.
Maybe we can talk with an example later if it's Colin now later. Okay. So that's the point. Like if we are in a pure situation, every time we call call by need, we get always, it's like memorization. It's like, I think, memorization version of call by need. Anyway, it's like dynamic programming. So basically we are, as Mark said, the runtime. The runtime system is basically doing that with time. So everything in Haskell is basically an expression, and it's unevaluated until evaluated, of course, and it's called thunk.
Can I ask a question?
Sure.
Does thunk imply only one evaluation or evaluation every time?
No, it's one evaluation. So every time the thunk gets substituted, I actually check like it's called RTM machine. That machine is actually swapping the thunk with time. It's not swapping time. It's basically filling with the value. So you see you have an expression 1 plus 2 plus 3. That will be 3 and would be 3.
My question is,
Anyway,
the term thunk, does that imply only one evaluation or evaluation every?
You want.
Only one.
We will actually. I'm going to show a trick that I didn't know. I found online like a couple of months ago on how to show thunks on the GHCI. That was pretty interesting. I'm going to show actually in this presentation. So what is a thunk? Yeah, I got it right. So what is a thunk? It's interesting. On Wikipedia says that thunk is somebody that was very tired. It was like 2 a.m. and basically was going to say think, but he's saying the past tense in the wrong way. Say thunk. So basically, think is a suspended computation evaluation, and it's the wrong past tense of think. It's from Wikipedia, so must be true. So unevaluated expression, exactly. Why we're doing that? Why we're fitting the whole heap with all these things to postpone evaluation? We are clear on that. We say this like in a million different ways tonight. Suspend computations. And this is the way that GHC is the compiler, the Haskell compiler. It's the most used compiler for Haskell. This is the way these runtime machines we were talking about earlier on achieve laziness. But wait, I'm a Scala guy. Scala has laziness too. Yeah, I'm going to show you. I'm going to show you how Scala is cool about laziness. Right? Yeah. Tell me more about Scala. Okay. Okay. First of all, some syntax here. If you don't know Scala, so this 3 question mark is basically a throw an exception. So you use that when you start developing and you don't know what you're gonna write. So you just put there, and when you hit that, it's gonna blow up. There's an explosion. Not implemented there. Fine. Same thing in Haskell. Mark actually mentioned earlier on undefined like this. So what I'm doing right now, I'm basically creating. So this is the REPL, the prompt. You can actually try them together if you want to do like a different test. So this is the prompt, Haskell GCI prompt. This is a list with 2 elements. The head of this list is 1, and the second element is undefined. So if I'm asking for the head, so I'm calling the head function to the list, I'm getting 1, and everything is fine, right? But same thing with Haskell. If I'm going to call the function drop 1 to the same list, so drop 1, as you can imagine, is just removing the first element. So what we get is actually a thunk. So this SP, is a colon SP, is a way to print the variable, and you can see thunks. So underscore means, I haven't evaluated, because we're doing nothing. All we've done, we just drop the first element. So we have a list with one element undefined, but we're not touching it. So as you can see, we have a thunk, with the list. Inside the first element is another tongue, undefined, but we haven't evaluated. That's why there is this. If here I was using print, just to use your example about I/O, if here I was using print, of course I need to show what's inside. But because I'm using this sprint, I'm not evaluating it. So this is an example to show the real laziness of Haskell. I know if you're thinking, oh, why we're doing this, all this mess, and we can talk about this later. But the point is, it's different. I don't know many languages that are able to do that. But Scala is able to do it. Let's have a look why.
Filippo.
What's up there?
Real quick, your example about the print, so that would be evaluated immediately because you have to print it.
Yeah, because as he said, we have to, if you're gonna print from the outside world, you're gonna say, could you please show me the element inside the list?
Right.
So the runtime machine is gonna open the list, it's a tongue, look at the head, the first element. What's inside the first element? Explosion. Like here, what I'm doing here, I'm calling print, calling head on the rest. So basically, rest is, as we said, is a list with one element, and we're gonna say, oh, could you please print that element? Explosion. Okay?
Yeah, start printing the only bracket before it explodes.
What's it again, sorry?
Oh, because, actually, no, hang on. It says head, isn't it? Never mind.
You know what? I need to show you. Okay, if you're not familiar with Haskell, this dollar is a way to open a parenthesis here and have another one here. So basically, I'm saying head rest and then pass the result of this into print. So every time you see this dollar in every Haskell program, that's the meaning. Look, Haskell syntax is super simple. Okay, so please, there's not many things. There are not many things.
Fourth syntax is simple.
Just the syntax. Just the syntax. Semantic is another thing. No, seriously, interrupt me anytime if there's something in the syntax that is not clear. And this is Haskell. Yeah, if we create in Scala the Roy Jenkins list, as soon as you create this, explosion straight away. Okay? But, I mean, Scala is not bad, because in Scala we have lazy, in a language we have this lazy thing. We can say, oh, you know what? This lazy val A is 1. No explosion of this 1. Sorry, lazy val B is a triple question mark. No explosions. It's lazy, okay? We don't evaluate it. Now the question, what if I do a list of 2 lazy values in Scala? That's the question. The answer could be the answer, or if you don't know Haskell, could be it depends. If Scala is doing call by value, call by name, or call by name. It's not doing call by name. In Haskell, you can do call by value, call by name. List is not doing call by name. So it's gonna explode. Okay? It's doing like Python is doing, like C is doing, like everyday language are doing. So basically, it's going to evaluate those lazy val and will explode. That's fine. We're going to keep going. We're going to do the ethic list, like from the ethic developer, you know, the one that cares about the team and want to write code that doesn't blow up on some other people's face. Oh, sorry, question.
Just to understand, so isn't there a way in Haskell to force it to evaluate? So not.
There is a way, and I try to not use it, and I try to don't even remember, but there is a way. No, there is.
So the default in Scala is not lazy? And
No.
default
In
Haskell
Scala,
is
it's
lazy.
lazy. You should ask them.
So
Scala.
it's a separate question. So in the default behavior in Haskell is lazy,
Yes.
and the default behavior in Scala, which I don't know anything about, is not lazy.
It's called, normally with function is called by value. Well, you can specify call by name. You simply use like a fat arrow on the right before the type. So it's up to you. You can specify either. But honestly, every single function you see like on GitHub, on any library, there's no much call by. Maybe it's a big statement, this one. I don't know, it depends. But if you look in our code base, there's a lot of call by value. Okay, let's put that way. So the ethic list from the ethic developer is the one that doesn't, they want to use like the call by name. So just to understand this very cryptic syntax, basically I'm creating a string that is actually the same as the Haskell list. Okay, it's a list where the head is called by value and the tail is called by name. So that's exactly what we expect. So this list is made by one element, 2 elements. So as you can see here, we know the head of this list, but we don't know the rest, the tail. Okay? So this thing is not exploding in our face. So if we call head 1, and everybody's happy. But now, if we try the same thing, we ask, for instance, for the length, explosion. I mean, it's just the length. I don't want to know what's inside here. I didn't ask to print anything. I just called for the length. Okay, explosion. Okay, I don't know what to tell you. I don't know what to do. It's fine. So here's the trick. This is Haskell again. Haskell. So if you set for some reason, basically I'm trying to unify this type into the integer. That's the only reason why I'm using this crazy thing. But the point is, if I'm calling the first element, fine. If I'm calling the list, the length of the list, it's 2 works. No explosion. So nobody evaluated this one. That's why the sprint gives me the list with the, I don't know, there's a thumb here that I haven't evaluated yet.
So that only works if you set that flag at the beginning?
Oh, this flag is to, no, it works even without. This flag is to run this. If you don't use this flag, here you get, I have a list of, I don't know which type.
Okay.
So it's doing the same thing, it's just to print this. That's a good question, so I was not clear about that. But I was trying desperately to show this way, and without this thing, I was not able.
I think
So,
we had numeric literals are like all in Haskell. So that it could be one, it could be a double, it could be an integer, it could be complex, whatever.
Right.
So, okay, that's just to show, yeah, Haskell is cool. No, Haskell is just using laziness up to its core. Okay, everything is a thumb. So, just to try to sum it up and wrap it up, this thing. So, Scala is a multi-paradigm language. We all know it. We try to be functional, try to do everything, but in its heart is imperative first. And when I say imperative first, what I mean, and there's an article about it here, it's that we need to think about, do I care how things are evaluated, which order things are evaluated? In Haskell, that's not the case. I really, seriously, you don't really care when you write Haskell. You don't need to know it, okay? You do
End up times where, you might get memory leaks.
Yeah, but that's the bottom side. Yeah, you can have memory leaks. That is true. That's the downside of it, yes, of laziness. Because you don't know how much space you're going to need, especially if you use like auto-folds and...
Yeah, you kind of, so the classic example is if you want to take the average of the long list of numbers, and if you do it kind of naively, and you say, well, give me the sum and then divide it by the length, that means you have to keep that whole thing in memory the whole time. So that's when you get like big explosions. If you've got a fold over it where it sort of just adds up, here's my running total, here's the number of things, then it all stays in small memories.
Another experience in Haskell is also that sometimes the program just hangs at the bizarre places, and I realize, oh, that's what's, if I'm trying to find the millionth prime or something. But I don't know when it gets done.
Exactly. So, I would like to say that Scala is imperative first, and many other languages we use every day. And Haskell is all about evaluation and simplification. Anyway, there's a cool answer on Quora here if you're interested on knowing more. This is the last slide. Why I personally like laziness is because I can write things concisely. As you did the example about the game. Sometimes in games, think about chess as well, all these games, you can have like an enormous gazillion of nodes of possible solutions you can search. You can actually, with laziness, you can define them very clearly and cleanly, and then you just explore with your algorithm just the states you can actually explore. Of course, you can have a memory leak because you can actually go. And the other thing is, you can also, with laziness, you can write very easily, you can work with infinite data structure, multiple infinite data structure. Maybe we can make another talk about just fold, fold left, fold right. Maybe that could be another talk. So this is all I got tonight. I hope you find a couple of things interesting. And there are questions.
Did you mean thonks?
Thonks. Thonks. That's a good one. Nice.
It's also worth mentioning that with strict evaluation of plot by value, you can get these kind of leaks as well because you kind of evaluate things before you actually need them. They stick around in memory until you're done. So it's kind of a dual situation.
Yeah, because if you don't stop using that kind of time, everything will not get garbage collected.
Well, none of this really solves memory issues.
No,
It solves
actually,
other issues, but none of them are.
No, you get new memory issues. You're gaining new memory issues. This is what he's saying.
Okay.
It's very common to have space leaks. That's why the profiling it's awesome in
But you can get that same kind of memory leak in a language where you're not doing laziness.
Oh, yeah.
Or you
I
just-
didn't want to.
if you're like maintaining pointers and things, you can
Well,
also
no,
get
no,
that. as well.
sorry, when I say memory leak, I'm saying that it's holding on to more than it necessarily has to.
Right.
Not that it's just disappeared the way a memory leak does in the C system.
So, but theoretically, I don't know if it's even possible to impart, but theoretically, the compiler, if it had like godlike knowledge, could look at your program and know that, oh, I actually don't need all of this, and like keep going.
That will actually happen. Like there's some, I want to talk about it, I'm talking about the GHC rules and the deforestation rules. So it's something where you map food, map bar, map, and so you kind of concatenate all these operations together. It looks like you're creating a list and then another change list and another change list. It can actually kind of rewrite it so that it's mapping all over once, and if the one at the end is creating it in a lazy way, you'll never ever have the full thing in memory at one time. So some of that technology exists. The problem is sometimes it doesn't fire, and then it's like, oh shit, now I've got to read Haskell code to work out why it's not firing.
Well, I'd assume there are some programs where, like, theoretically, there is some way to simplify it, but the system can't know what it is.
Right. I mean, you run into the decidability problems with
Okay.
that stuff. It's all kind of heuristics, really.
Okay.
So there was a question that I asked you.
Yeah, so I'm a Haskeller. I'm pretty familiar with the lazy evaluation in Haskell, but to see it how it's done in Scala, this was new to me. It's quite interesting, and I kind of found myself wondering, what is the practical application or use case for laziness in Scala? Because it kind of seems like at first glance it's trying to sort of do what Haskell does, but it's not all the way there, and that's kind of...
Yeah, it's a bit, okay, I can give you my answer. I don't know the real answer, but the answer is basically in Scala, everything trying to match some bytecode in Java. So think about something in Java, some Java implementation. So with the lazy thing, what it's doing, as far as I remember, like kind of closure, like anonymous function, something like that. But the point is, at some point, it needs to map to a class. So that's why it's doing that. And they didn't go like, you have to decide at some point, what should I do? Like go to purity, or I will be like halfway through, half baked. You can do most of it. That's I think the philosophy behind that Scala. Try to be. I mean, you have to think about it. 11, 12 years ago, they started like Martin Odesky started doing Scala, and was like, okay, let's try to be functional. But 12 years ago, now there's more eager on trying to be laziness. But back then it was like, well, let's give some like not first citizen laziness thing.
Is there like a situation, say you're writing some sort of practical application, maybe for your job or what have you, where you say, oh, okay, here is the perfect situation in Scala where I want to make this variable lazy, and here's why. Like, is there something?
Like a really obvious example would be generators in Python. Anytime you use them, you're taking advantage of the lazy evaluation strategy.
Yeah, I think it's exactly the point, yes. No, not generators like simple ones, but when you actually do computation and you keep doing yield everywhere,
And you might not consume the whole thing.
Yeah, exactly.
So you have generators, you have enumerators in Ruby, and then even in languages like JavaScript, you can still implement laziness where just instead of returning a value, you return the anonymous function that will return a value and just keep going off of it.
That's the way to do it in a language,
Yeah, so like all this can be used in like any language you want, it's just that these languages make it a lot easier to do. Yeah.
Is there a way to, well, some of these lazy, as lazy evaluation happens, the consumer memory, but what kind of control is there knowledge? You still have erasing whatever resource your memory is allocated.
That is tough. I think, to be honest, there's so many people got worried about Stack Overflow. Not Stack Overflow, more about memory exhaustion in Haskell. The thing is very hard. You need to, when you write, you need to make things, you need to be aware. But again, the profile is, I'm a newbie, but the profile is very good. And actually, the thing, you can see the thumb. If you didn't do a talk just about that, you can actually see a graph of the thumb at every, at every step of your application. You can actually make like a graph of that. Also give you, so when you debug, you basically debug code at compile time. But that's still a cool thing. But normally, the languages you do that at runtime. But anyway, you can run, there's also many ways to run even time, Unix time. there are some parameters I found in the Haskell community. You can actually ask for, oh, how much memory do they use? What's the maximum amount of memory? You know, things like that. But anyway, for me, it's just empirical. I don't know if you guys or if you have any other way
I've actually
to.
had a memory model for some time. I think you just have to start to get used to thinking, oh, this thing, I have to evaluate it in a certain way, like the average example. You know, you kind of have to say, I have to consume this in a way that I'm using one chunk of it at a time, and then I let go of the bit I was holding on to. Keep holding on to it, the garbage collector can't get to it, and holding it in memory, and everybody's happy.
Makes you wonder if that, instead of thinking in that particular way, that that could be replaced by a negative space.
Yes.
Can we go back?
So is the main trade-off with if everything is going to be lazy, that then you are dependent on the implementation for how it gets evaluated, and you have to have some knowledge of it in order to avoid those memory leaks?
Well, it's not like a particular implementation. Like, there's a fairly clear semantics of how it gets evaluated.
But I mean, like, you don't, that's just because Haskell happens to do it that way. Theoretically, it could be done in a number of different ways, right?
There are more constraints on it than you think, because, I mean, you have, like, there's a constraint that it has to, anything that would evaluate with strict evaluation still needs to evaluate with lazy, and there are some other cases that they still have to work, and if you evaluate anything at the wrong time, you might go off into never, so that there are quite, it's been a long time since I looked at it, but there are quite strict rules about when things get evaluated.
But you tend not to have knowledge of those when you're writing stuff?
Well, yeah, you worked out how to do strict, call by value kind of semantics. That was the thing you had to learn.